హలో ఎవ్రీవన్, పబ్లిక్ ఎగ్జామినేషన్లో క్వశ్చన్ నెంబర్ 24 మనకు అప్లికేషన్స్ ఆఫ్ డిఫరెన్షియేషన్ టాపిక్లోంచి మ్యాక్సిమా మినిమా అనే కాన్సెప్ట్ పైన కంపల్సరీ ఒక 7 మార్క్స్ క్వశ్చన్ ఫ్రేమ్ చేస్తాడు. రెగ్యులర్గా ప్రీవియస్ ఇయర్స్ ఎగ్జామినేషన్స్లో ఏవైతే క్వశ్చన్స్ రిపీట్ అవుతుంటాయో అవే క్వశ్చన్సే చాలాసార్లు అడుగుతూ ఉన్నాడు. లెట్ us డిస్కస్ ఫస్ట్ క్వశ్చన్. Find two positive numbers whose sum is 15 so that sum of their squares is minima అంటుండు. డబుల్ డెరివేటివ్ టెస్ట్ ఐడియా ఉంది కదా. సో డబుల్ డెరివేటివ్ టెస్ట్ యూజ్ చేస్తూ మనం ప్రాబ్లమ్ సాల్వ్ చేద్దాం. హియర్ వీ నీడ్ టు ఫైండ్ టూ నంబర్స్ x and y. x plus y is given as 15 and the numbers whenever sum of their squares is minima. Yes. Let us suppose the two numbers are x and y. Let required numbers, they are x and y. Given that sum of these two numbers is 15, implies we can write the value of y equal to 15 minus x. This is result 1. Here sum of their squares should be minima. Since sum of their squares is minima, implies x square plus y square to be minimum, and also you can write x square plus y value 15 minus x whole square to be minimum. Here assume that the minimum function f of x, that is equal to x square plus 15 minus x whole square. If you differentiate this, we get f dash of x value, x square derivative 2x, 15 minus x whole square value 2 times of 15 minus x multiplied by minus 1, implies f dash of x value become 2x minus 30 plus 2x, implies f dash of x value written as 4x minus 30 it is. This is second one. Next, its double derivative if you write, it become 4, which is more than 0. To get maxima minima, we need to write f dash of x equal 0. So here, to get minimum value, let f dash of x equal to 0, implies 4x minus 30 is 0 and the value of x equal to 30 divided by 4, that can be written as 15 by 2. Since x plus y equal to 15, implies we get y value also 15 by 2. And here double derivative more than 0 implies f double derivative at 15 by 2 gives the result 4 and is more than 0, implies f has minima at x value 15 by 2 comma y value also 15 by 2. This is your answer, and let us move to the next question. From a rectangular sheet of dimensions 30 centimeters into 80 centimeters, 4 equal squares of side x centimeters are removed at the corners and the sides are then turned up so as to form an open rectangular box. Find the value of x so that volume of the box is greatest. That is the question. There is a rectangular sheet, its dimensions given as 30 centimeters and 80 centimeters. At corners, x centimeters each side, a square on 4 corners removed, and then that sheet turned as to form a rectangular box, and the volume of box should be greatest, then what is the value of x? This is the question. Let us suppose I am going to select a rectangular box. Rectangular box I am going to select with dimensions 30 centimeters and 80 centimeters. Yes. And at corners, 4 squares are removed. Each side is of length x units. Here I am going to write the dimension of rectangular sheet. Length is 80 centimeters, width is here 30 centimeters. Suppose that 4 squares at corners with x centimeters are removed. When you remove 4 corners, then it becomes 30 minus 2x centimeters, and length become 80 minus 2x centimeters, and after that it is formed as open rectangular box it is created as open rectangular box. Yes, it is formed as a open rectangular box, and dimensions are given. This is, suppose that the open rectangular box. Here I am going to join this. This is open rectangular box. Here length should be 80 minus 2x, width is 30 minus 2x, and height h is x centimeters. Here the condition volume of the box should be greatest. I am going to write volume of the box. Volume of the box formula L into B into H. Here this is entirely function of x. Why? Because L value 80 minus 2x, B value 30 minus 2x, and height is x units, implies we get function of x 80 into 30. First I am multiplying these two, 2400. Next 80 into 2x, 160x minus 60x plus 4x square multiplied by x it is, implies f of x written as 4 times of x cube minus 220 of x square plus 2400 of x. If you differentiate this, we get f dash of x, that is 12x square minus 440x plus 2400, and double derivative written as 24x minus 440. This is result 1, and this is result 2, and this is result 3. To get greatest volume, to get maximum volume, extreme values for extremities you have to write f dash of x equal to 0. Let f dash of x equal to 0 implies here 12x square minus 440x plus 2400 equal to 0. Yes, I can write 3x square minus 110x plus 600 equal to 0. Next, now I am going to factorize this. Factors of this we get 3x square minus 90x minus 20x plus 600 equals 0 we can write. Yes, I am going to factorize this. Yes, in the next step we get, if suppose 3x common, we get x minus 30 and minus 20 common, x minus 30 equals 0. Implies either x equal to 30 or x equal to 20 divided by 3. Here, if you write x value 30 in this, what happens? Observe. F double dash of 30 first I am going to write, and then we go for f double dash of 20 divided by 3. If you write x value 30, 24 into 30 minus 440 implies double derivative at 30 become positive quantity. But when you write f double dash at x equal 20 by 3, it is 24 into 20 divided by 3 minus 440 implies double derivative at 20 divided by 3 become 160 minus 440 implies double derivative value become negative. Yes, when double derivative is negative, there the function f of x has maxima. Therefore, I can write at x equal to 20 by 3, f of x has maximum. F of x is maximum implies if x equal 20 by 3 centimeters removed at corners, if x equal 20 by 3 centimeters size squares are removed at corners, then there exists maximum volume. Yes, this is